This is Mr. Weiner for today's lesson, section 3.5, ratios and proportions. The first thing we want to ask is, what is a ratio? A ratio is a quantity that uses division to relate two quantities measured in the same units. So what we mean is, there's the three ways to write a ratio are A to B in words, A to B with a colon in between, that's the same thing, or A over B in fraction form. Just a couple things to keep in mind. A and B here both are numbers, so we could really write like 6 to 2, for instance. That would be a ratio, or that would be the same as 6 over 2, which, by the way, that reduces to 3 over 1, or 3 to 1, like that. Couple of things to keep in mind. Since this fraction here, B is the denominator, that means B is signifying, or A is being divided by B, excuse me. So we have to keep in mind that we're never allowed to divide by 0. That's, remember, one of the rules of math. So B is not allowed to be 0. That's one rule to keep in mind. And the other rule to keep in mind is that the order in which the ratio is written matters. So going back to this 6 to 2 example, 6 to 2 is not the same as 2 to 6. Just to make sure, we're going to go through this example here. If you look at the Vikings record of 6 and 4, in other words, they have 6 wins and 4 losses. We could write that as a ratio. So we could write they have 6 wins to 4 losses. Notice how I wrote that out in words. I could write it just as easily as 6 colon, oh, excuse me, not 2, 6 to 4, which simplify, that's the same as reducing a fraction. Again, that means we're going to write that as 3 to 2. Why is that? Because we can take a 3 out of both parts of, or excuse me, we can take a 2 out of both parts of this ratio to reduce it to 3 to 2. Just to further this example, we could also write this in terms of wins to games played. So in other words, they have 6 wins to 10 games played, or 6 wins out of 10 games played. In this case, we could simplify this ratio 6 out of 10 to 3/5 by taking a 2 out of both the numerator and the denominator. This 3/5, that's actually the same way that you would calculate winning percentage. So 3 divided by 5, you could put that into your calculator, and that actually would be their winning percentage. So you can think of winning percentage actually as a ratio. Just a couple more ratio examples here. We're looking at ratios and seeing if they're the same or not. So 5 to 4 and 15 to 12, are those the same? Turns out they are. Why is that? Well, we can think of it two ways. We can think of it as multiplying the top and the bottom of the fraction by 3 to this left-hand one, then we'll get 15 out of 12, which you see matches the ratio on the right. Or sometimes it's better to think about it in terms of simplifying. So in that case, we'd be dividing by 3 on both top and bottom, in which case we'd get 5 over 4 on the right-hand side. And again, that matches with the original ratio on the left. This next example looks just a little bit different, but it turns out that's actually the same type of situation. Remember the colon for the word to, or the bar for division, those really mean the exact same thing. So we could rewrite this as 4 over 3, this right-hand ratio. So now, if we look at it that way, are 12 over 9 and 4 over 3 the same? Well, it turns out they are. We can take out a 3 on top and bottom on the left-hand side, and we end up with 4/3. And of course, obviously, it's the same. So it doesn't matter that the colon's in there because it's still the same ratio. And lastly, here we have 5/4 and 4/5. Now, what's going on here? We've got one with a bar and one with a colon. That doesn't necessarily matter, but be careful now. How do we write this second ratio? If we wrote that as a fraction, it'd be 4/5. You see how the numerator and the denominator are switched from this first one? Remember, back at the beginning, we said it matters what order the numbers are in. So these last two are not the same. So to sum it up, first two ratios are the same. Second two ratios are the same. Third pair of ratios, not the same. We're about to change gears here and move to proportions, but before we do that, I want to work through a word problem. We're just going to do this without reference to anything other than our own intuition. So the problem here, we have 5 people get together and order a pizza. The total is $20. They agree to divide the cost evenly, but when the pizza arrives, only 3 of the people have their money. How much money does the group have? Well, there's a couple ways to think this through. The way I would think it through would be to first ask how much money, or what question are we asking? And that question is, how much money does the group have? So what unit should the final answer be? Well, let's see. The final answer needs to be money, so it should be in dollars. So just to remind ourselves what it is we're looking for. So I'll put dollars question mark here, so we know that's what we're trying to find. So now what do we have to work with? Well, the total, they ought to have $20. So should have $20, but they don't. They're going to have, are they going to have more or less than 20? Well, let's see. Not everyone brought their money, so they're sure not going to have more. They're going to have less than $20. Now, what exactly are they going to have? Well, let's see. There's 5 people, and the total is $20. So how much should each of them bring? $20, 5 people. How much should there be? There's going to be, if they divide it up evenly, which we said they did do, we're going to take $20 and just simply divide by 5. So $20 divided by 5 people, that gives us $4 per person. So now that we know that, what do we need to do to figure it out? Well, 3 of them did bring their money, and nobody else did, apparently. So if 3 of them bring their money, how many did each of those 3 bring? Well, each of them brought $4, we just figured out. So $4 per person times 3 people that actually did bring their money. What does that give us? That gives us $12. So that should be the total amount. And that's just thinking through this problem. Now in a minute here, we're going to see another way to work this same problem using what we're about to learn. So hold on to this. Don't lose track of it, but we're going to, it seems like change gears here, but it's really the same thing. So what is a proportion? I keep saying we're going to use a proportion to solve this problem. Well, a proportion is just an equation that states that 2 ratios are equal. So remember, we said a ratio is something like A to B or C to D. And what's an equation? Well, we've been learning about those. That's just a statement that sets 2 expressions equal to each other. So it needs to be an equal sign. So a proportion is going to look something like this. A to B equals C to D. Now, I wrote it with colons, but usually in equations, do we see colons? No, we usually don't. More often, you're going to see ratios written in fraction form. So it's going to be in the form A over B equals C over D. And this is really the form to keep track of. You really don't need to worry about this too much. I just wrote it again so we could review the different ways of writing a ratio. But a proportion is generally going to be 2 ratios set equal to each other, and those ratios will usually be in fraction form. So going back to this pizza problem, now I don't have the problem up in front of me anymore, so I'm just going to write down the important pieces of information. And this is often a very good problem-solving technique. It's just writing down the important information. Get it out of sentence form so you can just quickly see what you want. So again, remember what did we say we were looking for? We're looking for an amount of money. So total money present, we'll say. and I'm going to put a question mark next to that because we don't know what it is yet, remember. So total, as in total money they should have. I'm just going to leave it as total money since we said total money present up here. That should distinguish them. So remember, this is how much they should have. If we look back at the problem that they tell us, that's $20. Now, if we kind of follow the same format, we're going to say people with money present, or just people with money. And what was that? They said only 3 people remembered their money, so that's 3. And then people total is the other quantity I want to know, and that, of course, we said was 5. Now, the reason I did total people instead of, say, people that forgot their money is because I want it to be the same. I want the situations to be the same. So if I have total money and total money present, then I want total people and people with money present. You see what I'm saying? I don't. If for these two to be the same situation, it needs to be like this, or it could be, say, money present and money missing or something like that. But that'd be a different problem. They gave us the total money that there ought to be, so we're comparing that to the total of number of people that ought to have brought money, which is all of them. So setting it up as a proportion, 3 out of 5 people brought money, right? And so that's equal to the ratio of how much money there should be. And remember, that's our unknown. So oops, we don't want a dot there. We want an equal sign. So the total money present divided by just the overall total of money that there's supposed to be. So 3 over 5 we can set equal to, we'll put our unknown as x. So x, get rid of that question mark, x over 20. We'll put a dollar sign by the 20 just so we don't forget. Now, what do we want to do here? Some of you are probably going to remember the cross multiply method, which is a perfectly good method, but let's sit tight on that for just a second and just talk through how this works as an equation. So remember, this actually turns out as just a one-step equation. You have one unknown and then you have some numbers. So remember, if you're trying to solve an equation, you're trying to get the variable, x in this case, you're trying to get that variable by itself. So how can you get the variable by itself in just one step? Well, let's see here. We've got it's divided by 20 right now, so the inverse operation for that would be, let's see, can we do anything with addition or subtraction? No, because there's division here. So we're going to have to multiply is what it turns out. Okay, we're dividing, so we're going to multiply to cancel it out. Now what will we multiply by? We'll multiply by 20, so we can cancel that denominator. Now if we multiply by 20 on the right to keep the equation balanced, also multiply by 20 on the left side of the equation. So that cancels the 20s. Now on the right, we're going to have x by itself. On the left, we're going to have 20 times 3/5. Now, let's see here. 20, I can rewrite that as 20 over 1 if that's helpful. You don't have to do that, but sometimes it's helpful to remember what's going on here. I could multiply this 20 by this 3, and that's perfectly fine. Or I could just go ahead and cancel the 20 with the 5 in the denominator, kind of go across the fractions here to get 4, and then when the 5 will reduce all the way down to 1. So what do we have left on the left? See, we have 4 times 3 over 1 times 1. 4 times 3 gives me 12, and of course I can disregard the denominator since that's 1, and we get 12 equals x. And remember what x was. X was an amount of money, so x equals $12. Now that agrees with what we calculated before, which is good because that we were just using common sense before, so hopefully this new method is going to agree with what we found by common sense. Otherwise it wasn't a good method after all. So here's our final answer. X equals $12. One last problem here. Well, actually there's a couple more, but One more problem here. This is another way that you can sometimes see proportions written. They'll say 3 is to 7 as x is to 21, just as an example. It could be any numbers in there. But 3 is to 7 as x is to 21. How do we put that into a proportion form? Well, let's see. We've got 3 to 7. See that? 3 to 7. Just disregarded the is here, which if it's helpful for you to see it that way, you can feel free to do that. The as kind of signifies an equals, and then we have x to 21. So x to 21. So if I'm going to write an equation, 3 to 7 x to 21, remember how we said we usually write proportions? We usually write them in fraction form. So 3 to 7 is 3 over 7, and x to 21 is x over 21. This is a good time, too, to review cross-multiplying, because that is a good way to solve proportions. So the best way, the foolproof way to remember cross-multiplying is to literally make the cross. So denominator of one fraction with the numerator of the other. So 7 goes with x, 3 goes with 21. So when we rewrite that, we're going to write 7x on one side of our equation equals 3 times 21 on the other side. So 7x in this case equals 63. That's 3 times 21. Now if we divide out the 7, we're going to end up, now let's pause here. Why did we divide by that 7? We divided by that 7 so we can cancel the 7 on the left side of the equation, and then to keep it balanced, we did the same over on the right. So when we did that, x equals 63 divided by 7. Let's see. 63 divided by 7, that should be 9. So x equals 9 is what we just found out. Now the good thing about the cross-multiply method is it would work just as well if our variable was in the denominator. So if we had something like 3 over 7 equals 9 over y. See, we could still do the exact same thing where we make our cross. So 7 times 9 equals 3 times y in this case. And now if we do that, what do we get? We get 63 on the left equals 3y. What are we going to do to get rid of or to get the y by itself? Well, we'll have to divide by 3, so we'll do that on both sides. And 63 divided by 3 will give us 21. So y equals 21. And see, it works just as easily this way, whether y or whether our unknown is in the numerator or in the denominator. We just got 2 more examples to wrap this up. We'll do this first example simply by algebra. So we're not going to do the cross-multiply method for this one. So to get x by itself, let's see. X is with a 2 as its denominator right now, so x is divided by 2. How are we going to get rid of that? Well, we'll have to multiply by 2, so we'll do that on both sides of the equation, again, keeping it balanced. So we'll cancel the 2 over here, and on this side, 2 times 6 over 4, we can go ahead and cancel the 2 with the 4, so we'll get 1 on top and 2 on the bottom. So now with all the smoke clears, we've got 6 over 2 equals x, or what's 6 divided by 2? 6 divided by 2 gives us 3, so x equals 3 on this first one. Now the second one, just to get a couple techniques in here, let's do that by cross multiplication. So we've got 9 times 4 and a times 3, so 3a equals 9 times 4. Now for some reason, let's say I don't feel like multiplying 9 and 4 out. It's really not too difficult, but let's just say I didn't want to. We can still do the same sort of thing we did on the left side, and we can just go ahead and directly divide by 3. So divided by 3, again, because we're trying to get a by itself. So those cancel. So we got a equals 9 times 4 over 3. And since I didn't multiply that 9 and the 4 out, what am I going to do? Well, I'll just go ahead and cancel the 3 with the 9. So the 3 will go down to 1, And the 9 will go down to 3 when I take a 3 out. So now on top we've got 3 times 4. On the bottom we've just got 1. So A equals 12, it looks like, in this case.